You know, when we think about industrial revolutions, we picture steam engines, factories, the dawn of the internet, things that completely reshaped our world down here on the ground. But the next one? It's not happening here at all. It's happening hundreds of miles above our heads in the silent, zero-gravity world of Earth orbit. And trust me, it's going to change everything.
Just think about it for a second. What if, instead of having to launch every single nut and bolt from Earth, we could build massive structures right there in space? What if we could manufacture materials that are literally impossible to create down here? Or what if you could just call a mechanic to go fix a satellite worth hundreds of millions of dollars? It sounds like something straight out of science fiction, right?
Well, it's not. This is real, and it's happening right now. Back in 2020, this spacecraft, the Mission Extension Vehicle, flew up to a communication satellite that was basically running on empty. It docked and became a brand new engine for it, giving it another 5 years of life. The age of the space mechanic has already begun. But to really understand how we got here, we need to rewind the clock a bit. So let's start with what is probably the greatest construction project in human history, piecing together the International Space Station. This right here is the integrated truss structure of the ISS. The best way to think of it is as the station's spine. It stretches over 100 meters, that's as long as a passenger jet, and it holds everything together. The giant solar arrays, the cooling radiators, the robotic arms, the whole shebang. It was just an absolutely incredible feat of engineering. But, as you can imagine, building it was anything but easy. It took more than 10 space shuttle missions over 9 years to get it all put together. And in 2007, right in the middle of a really critical operation to move a huge solar array, disaster struck. As the array was unfurling, a guide wire snagged, and it tore a nasty 2.5-foot gash right through the delicate panel. Not good. Okay, so the deployment is stopped, and the problem is huge. How do you possibly fix this? You're 250 miles up, with no spare parts, and the nearest hardware store is, well, on another planet. So engineers and astronauts had to get creative. They designed these things they called cufflinks using spare aluminum and wire they just had lying around. And then, in one of the most nail-biting spacewalks ever, an astronaut riding a giant robotic arm carefully, and I mean carefully, stitched the solar panel back together. It was just a brilliant moment of human ingenuity in space. So, putting things together in space is one thing, but what if we could go from simply building in space to actually manufacturing in space? Well, welcome to the Zero-G factory. Now, here's the thing about making stuff on Earth. Gravity is always getting in the way. It's constantly pulling on materials, causing heavier bits to sink and lighter bits to rise. It creates tiny, tiny flaws in everything, from metal alloys to crystals. But up in space, in microgravity, all of that just goes away. You can mix things that would never mix on Earth, and you can grow crystals that are almost absolutely perfect. And the results are just incredible. Up on the ISS, scientists are making stuff like ZB-Alien. It's a type of fiber optic glass so pure it could be 100 times more efficient than what we use for the internet today. Can you imagine what that would mean for global communication? They're also creating new superalloys that are impossible to forge on Earth, and even the next generation of semiconductors. This isn't just a science experiment anymore. It's the very beginning of a real orbital factory.
Okay, so we can assemble things and we can manufacture things. And that brings us right back to where we started. The business of keeping all our stuff up there running. Think of it as roadside assistance, but for orbit.
This whole new era even has a name, ISAM. That stands for In-Orbit Servicing, Assembly, and Manufacturing. And the big idea here is a total shift in thinking. For decades, satellites have been disposable. You launch it, use it, and when it breaks or runs out of gas, it's just junk. ISAM changes that. It treats space assets like real infrastructure that you can refuel, repair, and even upgrade. And the toolkit for these space mechanics is getting bigger and better. We already talked about the MEV, which is basically a jetpack for old satellites. But coming soon is the Mission Robotics Vehicle, or MRV. This is the real deal, a full-on mechanic with robotic arms that can inspect, repair, and even install these little mission extension pods, which are basically small engines that can give a satellite another 6 years of life. So when you put all of this together, the assembly, the manufacturing, the servicing, you start to see the future taking shape. And that future is all about robots, printers, and a serious need for some cleanup. So remember that crazy high-stakes spacewalk to fix the solar array? The future of construction isn't going to look like that. It's going to look like this. fully autonomous robots. They'll take pallets of raw materials and just build, assembling massive platforms, giant space telescopes, or huge solar power stations with almost zero human help. And the factory itself is getting a huge upgrade too. Companies are now figuring out how to 3D print with really advanced metals in orbit. We're talking about things like niobium C103, a super alloy that can handle insane temperatures. You could use it to print high-performance engine thrusters on demand. You need a new part for your spacecraft? Just print it. But with all this amazing new activity comes a very old problem, and frankly, it's getting worse. 141 million. That is the estimated number of pieces of space debris bigger than 1 millimeter that are currently whipping around our planet. From old dead satellites to tiny flecks of paint, every single one of them is a potential bullet traveling at incredible speeds. And this orbital junkyard has very real consequences. A recent report pointed out that satellites are having their lives cut short because they have to keep making these unplanned maneuvers. In other words, they're constantly burning their precious fuel just to dodge all this junk, which shortens their mission and costs millions. So let's just step back for a moment. We've gone from astronauts literally hand-cranking bolts on a space station to the verge of robots building entire cities in the sky. We've gone from being limited by what we can make on Earth to the incredible potential of zero-gravity factories. This is what our future above Earth is starting to look like. We are, without a doubt, at the dawn of a new industrial revolution, one that's building a powerful new economy in orbit. The pieces are all there. The servicing, the manufacturing, the robotic assembly. So the question isn't whether we can build it. The question is how we'll build it. Are we going to do it sustainably? Or are we just going to fill this incredible new frontier with the same junk and waste that has plagued our progress down here? That, right there, is the challenge that will define our future above the world.